Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Static Analysis of Scala Applications. Our speaker today is Suchakra Sharma, who is a staff scientist at ShiftLeft. Suchakra, thank you so much for joining me today. I look forward to hearing your presentation.
Hey, thanks, Charlene, and thanks everyone who is attending this webinar. I hope you enjoy what I have to speak about. I'll just begin with a small introduction about myself. I'm Suchakra. I'm a staff scientist at ShiftLeft. My day-to-day job is a lot in security analysis, but also it's about testing how different kind of platforms or different kind of languages can be statically analyzed. And I'll begin with this, and here is the agenda for today's presentation. So first of all, we will be discussing about some vulnerabilities in Scala apps. We'll take small use cases from one app, which is the Play WebGoat app. We'll then move on to understand what are some unique challenges which we face with Scala, and then a demonstration of how you discover one of the vulnerabilities, and then move ahead towards inserting Scala SAST in CI/CD. So just note that I have said that this is a webinar about static analysis of Scala apps, but this is more focused towards security analysis. So we use static analysis not just for finding linting, for finding any other kind of issues, but we also focus completely on security analysis. And I'll just come to the point like why security analysis is the focus. So let's begin with just getting familiarized with this. So who is using Scala, or why do people use Scala these days? And we are focusing on web apps mostly in this presentation, even though it can cover a variety of applications. So LinkedIn, Twitter, Zalando, Netflix, at least these are the places I definitely know who are using Scala, and up to some point for web applications. And why they want to use it for web applications. So the first point is that they do a lot of stream and data processing because they just have a lot of data which is coming in, customer data or data about their systems. And it becomes very easy when they're processing this data with Scala, because it's very tuned to do that. There are many libraries around it. And if they want to build an interface over it, if they want to interface with that data and do a lot of other things, it becomes very easy. Scala is high performance and high concurrency. So it allows your underlying infrastructure, web infrastructure, to be high performance and high concurrent. There are multiple OSS frameworks which are there, just like standard other languages and other libraries as well. For example, Play, Finch, Arca, HTTP, etc. You could mix and match them, and all of these frameworks have something good in them, something which is tuned towards a specific use case, something which is tuned towards another use case. So there's a lot of variety, but very similar constructs which are there in web apps. So this is one of the reasons why people are using Scala, and this is one of the places you'll see Scala. And I hope most of you are also using it in some form or another. So we'll take one example out of these frameworks. We were talking about Play, Finch, and Arca frameworks. We'll take one example of Play. So Play framework is very standard. If you have built apps with MVC pattern, you'll see the similarity exactly like that in all other frameworks, be it Spring or be it any other framework that you're using to build your web apps. So it's standard MVC pattern. There's a model view controller. There's a simple router which has all the registered routes. It's usually stored in the routes file. So you just list the routes and the handlers for those routes, and you just put it in that simple file. The router is responsible for invoking actions inside a controller. So an action is just a builder which builds an object which basically is going to handle the requests that are coming from the router. And the action that then updates the model. So it can be, for example, customer model. It can be data which is related to, if, for example, like if it's Netflix, I know they're not using directly like that, but then responsible for movie titles or things like that. So basically a controller, how a controller works, very standard. And the controller can obviously communicate with the storage and update data there, while whatever has to be updated for the view just then goes to the view. And the view has simple templates, exactly like any other MVC system, the view in the MVC system, where they are then updated directly. So nothing out of, very different or very custom here. It's very standard. What you'll see in some of the Play apps is just the nomenclature is different, and the way they are used, it's a little bit different. And obviously, some of them are in Scala, so they're very specific for Scala. So here's a small RC in Play WebGoat. So I'll ask you to just go ahead and look up Play WebGoat. It's you must have known what WebGoat is. It's a vulnerable application which contains some amount of vulnerabilities. And Play WebGoat is one of the, I would say, official WebGoat ports which have been done for the Play framework. So they are in the Play framework repository, so you can go ahead and just check it out. So inside that, we'll look at a small RC and see what's happening here. So this is the routes file which I was talking about here. So the routes file which we talked about before, this is how it looks. And inside this, you define what your HTTP method is, get, post, etc. And the route, and then who is going to control that route, so the handler for that. And inside this, we can see that there is a route called as attacker query simple, and it has a controller, attacker query simple. So you go in the controller, so it's a home controller, and you go in the controller, and you're just going to see that there is an attack query simple here, which is actually built by the action. So this method is built by this action, and it has an implicit request in it. So this is basically one of the patterns how Scala would work, how this Play framework inside Scala would work. So if you have a web app, you must be familiar with it. So what happens is that the data, which is the request data, which is coming from this route, can very easily enter via here, and this is all defined in the code. And what we can see here is that the address is then taking its the address value, which is a new value that has been created, is taking its value from the request parameter. So now we know that the request has some data, the attacker control data, which has now flown into the address. And eventually, in the next line itself, it's actually being directly used by sys process. So the Scala sys process is used for actually executing what's there. So this exclamation mark is kind of like a shorthand for executing something. So here, ping and then address is being used, and it's being executed. So this looks like a direct remote code execution, where an attack control value can directly be being executed by the controller. So this is a vulnerability. And similar to that, in the same example itself, and again, I'll just remind you, if you're on the GitHub repo for Play WebGoat, you can go in home controller and you'll see this. Similar to that is another flow, which we can see, where the address is now part of another string. It is becoming part of another string, which is composing HTML, and then that HTML is actually being sent as an HTML by this handler. So anything that can be attacker control here can be then returned directly on the page as a response. And this is obviously looking like an XSS. So, pretty dangerous again. So it's reflected, which means that any data that is coming through this server is attacker control, and the attacker can then take this link and give it to somebody maliciously and then say, hey, this is a very nice link. You can just click it, but internally their own logic is going to be executed when this gets executed by whoever is the victim. So this is an XSS, and we saw an RC. So we know at least 2 vulnerabilities which are there. There are many more in the application. You can go ahead and keep on looking at, how they are being exploited and see. But what we'll do is we'll go ahead and start mostly, focusing on these 2 and take them all through how static analysis could be performed on them. So one thing that is clear from the links that we have seen before, from the vulnerabilities that we have seen before, is that when you're writing them, when you're writing code like this, or when you're trying to debug code like this to make sense of where the data is flowing, who is being called, HTML is called here, OK is called here. So when you're trying to make sense of it, it's all like graph in your head. When you're coding, you would think in graph. OK, let me do this. I will branch here. Then I will use this variable. I will put this there. So, you are basically all the code is a graph, and we think in graphs when we are coding. So we should also think in graphs when we are debugging. We just hold on to that thought. We'll come back to it a little bit later. So what's happening in Scala these days, or in most of the other languages also these days, and how security analysis is used, is that since everything is a graph, the developers are like, okay, let's take one abstraction from the compiler world for Scala or for any other language, and we'll use it to define the rules that have to be checked. So there's something called as an abstract syntax tree. So I'll just assume that I'll just give you a very brief overview of what an abstract syntax tree could be. So if there is an expression like x equal to 2 plus y, then you could, and that's in, for example, like in C or any other language, you can then break it down and convert it into small tokens, x, 2, and y. And then you can also identify, oh, there's an operator, which is a plus, and then you can define all of them, into a very tree-like format. And what happens when compilers work is they take this high-level code, like S, ping, dollar address, and then break it, and then dot exclamation here, and break it down to tokens, and then create like a tree structure. And then they go through the tree structure to make sense of it. So what happens is that we pause this, generation of the compilers into this format, and we can then make some sense of it, and we start grepping it. So for example, we can then create a rule. So a rule here would be, oh, is there a call which looks like process, or it's shorthand, the exclamation? Okay. Does that have a parameter called as ping or calc or rm or something like this? So like a regular expression here. Is its type string? So do you have a string which is being executed? Is there a variable inside that string? And what would happen is that a normal tool, which is the state-of-the-art tools which are used in Scala, they would go through these rules, go through the tree which is generated from the expression, and then make sense of it. And if they are checked, and they would say, okay, yeah, this looks like a vulnerability. That's pretty straightforward, isn't it? The problem is that these rules are very, very wide. For example, it would look probably for this, it would say, yeah, this is a vulnerability, but it does not know if the address is actually variable which is attacker controlled. It does not know who is calling it, in which context this is being called. Is it a handler? Is it inside a handler? Or is it a legitimate use of an exclamation? We do not know that. So it would generate false positives. And if your regular expression checking, which you're doing with grepping, is too complex, then it can cause a lot of backlog, because the expression become huge and there would be a lot of CPU consumption. And the third, which I already said, is lacking semantic context. In which context is this being executed? But it still works, it would give you some vulnerabilities, some are false positive. You can sort through them and you would be, okay, fine, I get something out of it. The second approach would be to take this expressions at their actual face value. Basically take a lot of chunks of these code which other people are writing, identify which one are vulnerable, and make signatures out of it. So you'll take this, create a signature. Let's assume it's called as sig_n or something. This is a signature from your code from this expression. And then you try to match it how close it is to other signatures. And other signatures are defined based on certain traits. Okay, there's an exclamation. Okay, they're using rm, they're using a variable. So you create the signatures and start matching them. So again, the problem will be the same. It depends on how well the signature has been generated, what algorithm has been used to generate the signature. I mean, it's basically just characterizing and trying to catch everything. So it's like a big net, and the net has holes, and you're trying to, keep on fishing and trying to find out, okay, yeah, this fish is gonna fit, and I get something out of it. So there's not much determinism in this approach also, and obviously there's a lack of semantic context. We do not know when this was generated, when this in which context this statement was being made. We do not know that. So are there any solutions to it, or what can happen? So the current state of the art in integration. So this was the state of the art in discovery. The state of the art in integration also is this, that people would want fast code linting scans integrated in CI/CD, and that's very well possible. You can do simple linting, etc. in CI/CD. They're very fast. You can quickly find small bugs. You can quickly find issues regarding just syntax, or issues regarding how things are formatted. You can do that. The other approach would be to just use runtime agents integrated at runtime. So JVM agents, which you attach to your processes, and they'll try to catch things, like try to catch if these strings being coming in this route are SQLi or not. So at runtime. The other approach is slow SAST scans, which run in parallel in CI jobs. So you create a separate job, and these are very slow. I have dealt with folks who run this for multiple days. So they run scans and they run for whole weekends, and they just keep on waiting for like 5 days to get 10,000 results, and they would try to sort through them and see, okay, these are good, these are not good. So actual scans which run on graphs like we discussed here, generate an AST, go through whole of it, try to find who is calling who, try to find how they are being run, check them against rules. And this is complex. It takes days to run this. So this is kind of like the of the art. And other thing is very much developer focused code linting. So you're a developer, you have your IDE open, and you're just it gives you some alerts about, hey, this could be a possible SQLi, just check your SQL statement, or things like that. So it's not a concrete security evaluation, but that's what there is. So this is the state of the art on how security is integrated, static analysis security is integrated. And this is basically state of the art how this discovery of the vulnerability is there. So there is an opportunity here. What would you consider as next gen then? So for something to be the next generation in this, you would want it to be fast. You want low false positives and more true positives. So it needs to be very accurate, which means that's what it means. It needs to be very fast, and this is very difficult. We want to be fast as well as accurate. It needs to be integrated in CI/CD because, let's face it, everything has completely moved on to this autonomous system of integrating and delivering code. So we need it like that. And also it needs to be manageable from some sort of SaaS or an on-prem web solution, where you are not completely all the time sitting and running CLI tools, but they just run and you see some sort of results and you're okay with it. Okay, you don't have to disturb each and every developer. Go to their desk, look at item number 76531 SQLi. Here is a statement below, and copy paste it to them. You don't have to do it. So it needs to be a little bit manageable as well, because there's a lot of code which is being produced. And the most important point, it needs to be built on knowledge graphs of code rather than just grep and signature matching. So and this goes to the point of low FPs. So to reduce the false positives, you need something which is much more true. So you have complete knowledge and you want to identify. So how would we go ahead and building this kind of solution? So some of the things, we'll come back to the same example of this RC here. So you would look at this code, and a person who is a manual, auditor would ask some questions. You would want to identify if first this address, which is going inside this, is actually attacker control. So you would want to know if this is part of a function, which is a parameter of a route handler. So there's a route handler, attacker query simple. Is this coming from the parameter of the route handler? What is it type? So is it a request, or is it some another random variable? So you need to know what its type is. Is it part of an attacker control variable? And if it is, you would taint that variable and you want to follow it. You want to follow it all the way via certain methods or via certain operators, by equal to, addition, concatenation, division, or whatever. You want to follow it all the way down to a certain sink. And so you need to know that there is a definition of a sink. So an expert would know, and a manual auditor, that, okay, this is an execution that's happening, and I want to identify if this address which is coming inside this execution is actually coming from an attacker control data. So what a common pattern here is that there is some sort of data flow which is there. There is some sort of understanding of control flow and these values being passed all together, and an understanding as well of the context, where this is it an actual handler of a route. So all this information is there, and it looks very fluffy because as a manual auditor, you are having some information about yourself, information about what you know about the code base. So it looks very fluffy, but stay with me. You can actually convert them to concrete statements. How would you go about this? So the way to go about this is to take that knowledge which you are trying to reason with, this questions you are asking again with the code, and convert them to graph, and then ask those questions to the graph. And this graph should not just have AST, but should also have information about control flow and program flow. So what is dependent on what? So let's take the small snippet. So x less than 2, if x less than 2, foo x, else, there's a new variable, and x into 2. So yeah, so the AST would have information which is something like this. There is a predicate, there's an operator, x is less than 2, and it's going inside if else. So the information about if and else is control flow. So information about foo is only called if is called. And the third information is about exactly program flow, that y is dependent upon the value of x, which is dependent upon this construct of if x less than 2, or is dependent upon this call, which can happen. So all this information about code, once it's available, then you can have a query like this, a very high level query. Find if x is called as a parameter of foo only if its value is checked to be less than 2. Okay, and then you can have a answer like yes, it's true, or no, it's false. So once you can formulate questions like this, you can then probably ask questions like this. Identify if there's a variable going inside the process execution which is attacker control and is coming from this specific route. So a question like this then can be reasoned with. So what's coming out from this is that we do need a graph, and a very comprehensive graph, to ask questions like that. So now let's try to apply this into the example that we had. Okay, so you take this code and you convert it into an executable jar. So that's exactly what we need. And we converted into this graph format, this coupled complex graph format. And this is something which actually we developed inside ShiftLeft from the work by Fabian Yamaguchi. You can search his name and just search code property graph, and you will see a research paper which explains what's inside this. So I'll try to make it very high level, so you don't have to go through the research paper. So here is then this piece of code converted to a jar, and now you have this graph. So it's no longer this code, but it has all the information about the program flow, about the control flow, and the data flow. So it has all that information inside it, and now you can reasonably ask questions to it. So what questions would you ask, and what knowledge would you have over the graph? So you would then combine and understand a little bit more about the graph. So you would first, for example, try to find out if this process, which you see this exclamation here, is it a sensitive sync? Yes, it's a sensitive sync, and this is the knowledge that you are trying to embed in the graph first. And this is basically also what we call as security policies. So for each language and for each framework, you would have this information stored. Is this action a sensitive source? So there's an action being used here. It's a builder for the method, which is attacker query simple, and which is a handler. So is this a sensitive source? Yeah, it looks like a sensitive source, and it's having request as its implicit data. That also looks like a sensitive source. Is there any other method like toString, which is transforming this data somewhere? Can that be important for me? Yeah, it could be. So you have all this information as your knowledge, and then you take this knowledge and combine with the queries that you would want to ask. Is there a call to the process? Yeah, there is a call. Is this call containing a variable? Yes, that call is containing a variable. Is that variable containing data which is flowing from attacker controlled input? Yes, it is. So once the questions to these questions are, once the questions to answers to these questions are coming out to be true, then you can, probably say that, yeah, seems like an RC, you may be owned. So what we have seen is that once the graph is there, you need two things. One, intelligent queries, and an existing knowledge base which you have developed over the graph. And once that is there, you can then definitely say that this is a true vulnerability, and you're not depending upon just signature matching of this line, or just identifying that there is a variable, there is an execution. Okay, I would call it a vulnerability. So you definitely know that there is an actual flow coming from attacker control value to the address. It is a vulnerability. Which brings us to a small demo that we have, and I'll show you how a small RC that we have added, how our tool can actually identify it. And I'll use our tool here, which is a ShiftLeft NG-SAST, which can identify this. So it uses this information behind it, takes this code, creates this graph, and there are queries and a knowledge base which is there, and it's run over the graph, and it generates some results. And we'll see how those results are. So you can also go ahead and start analyzing your Scala apps if you would want here. And you can also, can you still see my screen? I think people can see my screen. I think it's fine. So, and then the third would be this link. You can go ahead with this link. This is different from, the link of a Play WebGoat, the official link. The reason is because it contains a small YAML file for GitHub Actions, which we have integrated. So it becomes pretty nice. Like you can quickly see here that on each pull request, ShiftLeft NG-SAST runs, and it generates some results which you can then view. And obviously, we are not just totally linked to GitHub. You can use any CI/CD system. The statements are very simple. You just have to run SL analyze and identify what jar you want to analyze, and it will automatically run. So you could run it on your own machine also. It does not need to be GitHub. So I'll just quickly switch to the demo mode now, and maybe let's see what we are able to see. Okay, so this is the Play WebGoat app which I was talking about, and as you can see, the routes are here, and inside this you can see that this is the attacker query simple, which contains a small RCE, and it also contains XSS. Okay, I think the RCE is replaced. Let me, because I have not merged the pull request, let me just merge it quickly so that you can now see. Okay, so this basically is these RCs which I had first removed and then I re-added them. So I'm trying to merge it. Let's see. It allows me to merge this. Okay. I don't know what the reason is why it's not allowing me to merge, but anyways, once that merge is there, we will just switch to this branch and you're actually able to see what the RCs are. So these are the RCs which are there in this specific branch. And what we'll do is we'll try to run our tool over this and analyze, whether it's working or not. So let's go to play WebGoat and we go to actions. I've already integrated ShiftLeft in this, so it has all these actions already. And we can then quickly go and run this workflow. Maybe something to do with this. Okay. I think the demo gods are not so happy with me today. Anyways, so once one of the workflows would run, they would probably look something like this. The ShiftLeft NG-SAST would run. It sets up the job, extracts the branch name, downloads the ShiftLeft CLI itself, and then go ahead and it does build and analyze. And once build and analyze is run, the analysis is ready with you and you can see. So by saying that the analysis is ready, it will take you to the ShiftLeft dashboard, and you'll see like a lot of your applications which are there, and they would be ready with you. And you can just search through your application, which is this specific application, and then you can click on your app and you can see all the runs which are there. So I've done 4 runs of it, and this was where the branch was there where I fixed some RCs and then I re-added the RCs again. So this is that specific branch. And this also shows that you can keep on tracking whether your vulnerabilities are reducing or increasing, etc. And you see the standard stuff. There's a critical vulnerability or a moderate. You can see them. You can see how your findings. We don't call them vulnerabilities. We call them findings because like true security folks, you never know if something is actually a vulnerability or not. You want to actually be 100% confident about this. So we call them findings. These are the things that we found, and what are their types. Then you can like quickly look at them. So for example, here is the one which was the attacker query simple. It was an anonymous function and also coming from an attacker control area. And this was in home controller, and then you can keep on seeing complete data flow of how the data from that request variable, which was inside here, which was basically this example that you were seeing, is coming all the way to this and eventually being used. So you see all this complete flow from the request and all the way down to string to process, which is basically Scala sys process, which is executing the process. So what we have done is we have understanding of the source, which is this home controller and on attacker query simple, because we understand that this is attached to a route and this is the handler of a route. So identification of this is what I was talking to you about, this knowledge which was there. So understanding that this is an attacker control route, And then we have the knowledge that there is a sink, which is string to process, and then we attach if there are flows between them. So if there is one, we identify what is the type. So this looks like it's a string to process. This something is being executed. And then we would classify it as, okay, it looks like an attacker command injection, which is coming through an attacker control route. So, and via some variable. So we would identify that, and that becomes a vulnerability. Similar to this, you would find a lot of other vulnerabilities which are there, and you can keep on going through the code and trying to analyze this yourself. This code is open source, so you can also build it, and you can start playing with ShiftLeft and start throwing this code. It's free for you to use, so no worries about that. And you can filter through different kind of vulnerabilities which are there. For example, here we have few XSS also. There's SSRF also. So the vulnerability which you saw here, the XSS vulnerability where HTML was used, and then address is used inside HTML, and then it was used there. You would also see the same kind of vulnerability here as well through some other variable or some other. So for example, this is in the attacker query simple. So you would see the flow of this going all the way from the request and going all the way to HTML. So this HTML variable is then finally used here. So this is the kind of depth you would be able to understand. And only once you have a true data flow, and only once you have a complete information about whether there is a data flow from a source to a sink, would you be able to say that, yeah, this is a true vulnerability, and this is very interesting, I should go ahead and investigate. So with this, I would start probably taking questions. If anyone has any questions, I'm here to answer them.
All right, great. Yes, there's plenty of time for a question and answer period, guys. If you have a question for Suchakra, please go ahead and use your GoToWebinar control panel and submit your questions. Let's go ahead and dive right on into what we've got so far. What are some of the challenges that you faced that are specific to Scala?
Okay, so as you all must be knowing, or the folks who work in Scala concretely must be knowing, is that Scala has a lot of these constructs which are very specific to it. So for example, I'll try to go back in my code and see, in one of the examples. So for example, you see this action here. Okay, so action follows like a builder pattern here, and which then returns you this method, which then method is attached, obviously. And it has some arguments like request, which are coming implicitly. And then what can also happen is that you can go ahead and have another function which is created inside and then used. The data flow discovery in this becomes a little bit of a challenge, and we have faced this challenge again and again in while we are trying to create these graphs. So I would say that that was one of the challenge. Beyond that, I think the discovery process of the data flow was pretty straightforward. It was not much challenging because we also support multiple languages, and we had that knowledge on how this static analysis had to be done here. That was okay. But constructs like this are difficult. Another one, for example, is like in Scala we have for each. So XS for each, and then you have the construct of for each. So X is not initialized there, and every time its value will change. So we still have to understand that it is part of XS and propagate the data flow there. So that's another challenge that we had.
All right, great. Excuse me. Next question. What are the differences you see between Java and Scala when it comes to SAST?
Okay, so I would say the biggest issue, or I would not call it an issue. I would basically call it the way we operate, or the way security has to be operated, is that Java is much more still extensively used than Scala. in terms of web applications, and I'm primarily focusing on web applications for this specific webinar. And in that sense, the kind of security information, the kind of CVEs to refer to is much more wider. And that's one difference. So you have a lot of reference to go ahead, and build and embed this security information that you have, the knowledge in this a little bit more better. Beyond that, I don't think like there's something very, very specific or some very big difference. It's almost the same. You have the jars being generated there, and from the perspective of security analysis, using ShiftLeft at least, all it wants is JVM bytecode. You throw it in, and it's going to analyze and then give you results.
All right, great. Once again, guys, plenty of time for questions. So if you do have a question, go ahead and use your GoToWebinar control panel and submit it. Next question here is, let's see, is Scala framework supported?
So we don't have specific annotations for Scala, but I think if there is interest in it, and if someone submits an application, the default engine will pick some of the few things, and if there's an opportunity, we can keep on tuning it, and soon it will be supported. And that's the process that is there for all security tooling. First the framework comes in, and then you annotate it, and you suddenly start seeing more information. So that's kind of the process here as well.
All right. Excuse me. Okay, next question. Can we analyze using tools that are in Java?
So I do not know if there's a specific Java tooling, but it's pretty much the standard. So it would definitely work here as well.
Okay. All right, great. Next question. Since you mentioned CVEs, is this tool focused on source code analysis or SAST only, or both?
Okay, so you can do SCA also, and you can also do SAST. So it's like a mix of both of them, and we are kind of like developing an experience where both integration of both is there. So let's assume that let's take a scenario where you are using unknown libraries, open source libraries which you have, and you have integrated them. So we would be able to also discover if these libraries are consisting of some CVEs, and then give that information to you, and at the same time go a little bit more deep and see how that library is integrating with your code. And because we have the knowledge of the graph, we can actually identify cases which are 0 days. And this is true. We have found 0 days right by analyzing the code, and it's specific to your code.
All right, great. Next question. Please, could you show us a way to embed this in CI/CD?
Okay.
Something you could show?
Yes, so I'll try to show how it was done for GitHub, but the process is the same. So for example, what happens here is that in GitHub, we have something called as actions. And when these actions are written properly, you can write them in YAML, and they start showing up here, and then you can run the workflow. But what I'll do is I'll go ahead and show you how one of those actions are and what goes inside it. Again, just to reiterate, this is not only GitHub specific. It works across any CI/CD system, because all you have to run is one simple command. And what I'm trying to do here is to actually show you how that command is written. Okay, that's the settings. It's in workflows. Okay, so what you have to just run is run this command. You could run this on your own system also. You could run in any other CI/CD system. You could run it on your laptop or anywhere. So all you have to do is fetch SL, which is the ShiftLeft CLI tool, and just do SL analyze, give the name of the app. So SL analyze app, my Scala app, If you have a specific branch, you could even tag that branch so it remembers that. And then just do, this is not necessary dash dash Java. I copied it from a Java app, so that's why it does not care. And then you don't even have to give dash dash CPG and just give the name of the jar. So here, I think the name of the jar is target dir app, and I think which is the play WebGoat jar. So all you have to do is just give this one command, and all is done. And we have integrated with Azure, with GitLab, with GitHub, or any CI/CD system, Jenkins or whatever, because all it requires is this one command.
That's really interesting. Okay, great. Next question there. Do you provide options to ignore issues in this tool?
Yes, there is an opportunity here. So for example, let's assume that this was not interesting. There is an option here, mark as fixed, or ignore. You can just click this and it will say one finding marked as ignored, so it's not going to show again. And you could also assign it to someone to be fixed. So if you have people in your place, you can then just assign them, and they would have to go ahead and fix this. So then the next time you're gonna see this, it probably is gonna show you that, oh, one person is assigned, and they are supposed to fix this.
Excellent. Okay. Excuse me. Just another quick reminder, guys, we have probably about 10 more minutes for question and answer. So if you do have a question, plenty of time here. So go ahead and send it on in. Let's see. ShiftLeft.com, or can we see it only, or I'm not quite sure what this one is asking. ShiftLeft.com, can we see it or only for our own samples? We're talking about.
I didn't understand that.
Yeah, me neither. I'm not entirely sure. Sri, if you want to give us a little more information for your question, I'd be more than happy to revisit it again. Moving on to the next one. What about prior to scanning, especially if you mature your DevSecOps practice?
Prior to scanning.
Yeah, I think that's a follow-on to the providing the option to ignore issues.
Okay, I also didn't understand that prior to scanning. Maybe can you identify, or try to explain a little bit? Maybe I can answer that then.
It looks like perhaps when Rostam was asking about whether there was an option to ignore issues in the tool, if it's something that can be done actually prior to scanning.
Okay, I think I understand that. So yes, of course. So once you have, I'll go through that, that kind of workflow as well. So for example, you have this, vulnerability, and now you think that, okay, this is something which is not, attacker control thing to me, and anywhere this specific method is used, just don't, show me this vulnerability at all. So there are two ways to go about this. One way is the way in which we also as ShiftLeft developers kind of do, and this is also mentioned in docs.shiftleft.io, and this is about security policies. So if you use ShiftLeft, we'll probably try to explain to you how these policies are working, or how you can write your own custom policy or things like that. So for example, you can identify that this is there is a sanitization function, and don't show me this vulnerability at all. So you can do that. There are commands for that. You can write the policies. There is information about how those policies work. Another simpler way that is coming up, I think in a month or so, or a few months, I cannot guarantee the exact time, is where in the UI itself you can just say, hey, this is fine, just don't show this to me ever when the next scan is done. So I think that's what it meant by prior to scanning. So knowing beforehand that you do not want this specific method or the specific vulnerability to be shown, and just exclude it. So you can identify that, and then it will stop showing up again, or it will just not scan that part.
Okay, revisiting the earlier question about ShiftLeft.com, Sri sent an additional message. Can we use for our sample program samples also to analyze vulnerabilities? And if so, can you please show a sample?
So sample programs, I would, which means like not play WebGoat or something else? Yes, of course. I mean, there are so many other vulnerable apps that you can just run and, probably like see. I don't think we have time to just quickly run like a complete new analysis, but I can show some examples which are there. There are some which we also have coded. I think it's called as ShiftLeft, Scala something. I don't know. Hello ShiftLeft Scala. Yeah, I think this was the one. So this has a little bit more vulnerabilities in it. So and a lot more variety. So you could go through that and simply just generate, just run. There's build.sbt. So all you have to do is sbt clean stage. It's gonna generate hello ShiftLeft Scala.jar in the target. Use the assembly jar, which contains all the other packaged jars inside it, so that the whole code is covered. And then you use either this YAML, or there's information on the docs how you can just run it with SL analyzers. I've been just saying, so you could just use something like analyzing applications. So here's like Scala. So all you have to do is just this, and use SL analyze app, and then the path of the app here, and then you can just quickly generate the scan, and it will work.
All right, cool. Hopefully that answered your question, Sri. Okay, next question here. Regarding configurability of the tool, is it possible not to fail a job in a pipeline if the findings are not high or critical, for instance?
Yes, definitely. So this is totally controlled by you, how you code it in CI/CD, in your CI or CD environment. So for example, here we do not fail the job. As you must have seen, the pull request runs. When the pull request is submitted, there was a check which ran, but it still like was showing that it's a successful check. Yeah, and it did not break the build, but you could also break the build here also. It's the same in any CI/CD system. You could just say it returns an error code, and then you can stop the build here.
Cool. All right. Okay, we're about 7 minutes to the top of the hour. I think we have time for one or two more questions. So there's time. If you have a question, go ahead and get it on in. Let's see. So here's a good one. What are some things to avoid to increase the performance in Scala?
Okay, I can give a few recommendations. So I'm assuming this is about performance of security scanning of Scala, and not performance of Scala itself, or software built with Scala. So regarding the security, what I would say is that try to not package application, the jars inside that big jar or war, whatever package you create. Try to not put packages which are probably fine, and you don't care about them. They are okay, and try to put as much as your code inside it. So in that sense, what happens is that since for example, let's take Apache Commons, or some sort of very famous package which you have inserted in Scala, which which we know and we have already annotated for vulnerable sources and sinks. You don't need to include it in your application anymore. So this reduces the surface of scan and the size of the graph that is going to be generated. And actually, this is also one of the ways why our scans are very fast, because we are able to limit the the scan to your code and the immediate code that is surrounding it, and not to any very deep a very deep library inside, which we already know and we have already annotated and converted into knowledge.
All right, so we're about 5 minutes to the top of the hour. I think that is all the time that we have for questions, but let me just do one final check through here. Excuse me. Okay, so let's, I think Rustam has clarification on one of his earlier questions. Maybe we can do it real quick. Can I configure the tool? This is going back to the CI question. Can I configure the tool not to fail the CI only if there are no high or critical findings?
Yes. Okay, so just to dig a little bit more deeper into that, you can, so ShiftLeft provides, I think it's in the docs also, build rules. Yes, so it's something like this. So you can add a ShiftLeft YAML file to your repository, and you can mute certain kind of vulnerabilities like SQL, etc. here, or you can also mute certain kind of severity and also put a threshold on what you would want. And based on this, the scan would either fail or not fail, or show you some other error. So you can go up to this granular level, like only show medium, only show high, or things like that.
All right, great. Well, we are about 4 minutes to the top of the hour, so unfortunately that is all of the time that we have for question and answer period. I do want to thank everybody who did submit questions. There were a lot of really good ones. If we didn't get to your question, I apologize, but please know that the folks at ShiftLeft are getting a copy of all the questions that came in, so I'm sure they'll be more than happy to follow up with you offline to get your question answered. Also, a quick reminder that today's event has been recorded, so if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I did mention at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is Jeff Y. Congratulations, Jeff. Second winner today, Leonard V. Congratulations, Leonard. Third winner today, Tom T. And our fourth and final winner today is Sri P. Congratulations, Sri. And we'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see it there, please check your spam folder. All right, well, I do also want to thank Suchakra for such a great presentation today. Lots of great stuff. I especially enjoy the demos, as I'm sure a lot of people know already. So I got a real kick out of today's webinar. So thank you so much. I appreciate it a lot. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.